You know, when we think of a volcano erupting, we usually picture that classic, dramatic scene, a massive explosion straight out of the top, a mushroom cloud of ash billowing into the sky. It's the stuff of disaster movies. But what if I told you that for one of America's most dangerous volcanoes, the biggest threat isn't what comes out of the top, but what could burst out of its side? Today, we're talking about Mount Rainier, the majestic giant looming over Washington state, and why its side-splitting potential is a unique and terrifying danger. Mount Rainier is an absolute icon of the Pacific Northwest. Over 14,000 feet tall, draped in more glacial ice than any other peak in the contiguous United States, it's a breathtaking sight. Millions live in its shadow, in places like Seattle and Tacoma, but Rainier is not just a pretty mountain. It's an active stratovolcano, part of the infamous Ring of Fire, and its specific geology makes it a ticking time bomb of a very particular kind. Most volcanoes have a central conduit, a main pipe that magma travels through to erupt from the summit crater. And yes, Rainier has had those kinds of eruptions in the past. But over thousands of years, the mountain has been weakened. It's not a solid cone of rock. Instead, it's more like a giant, unstable pile of rubble, held together by ice and its own sheer mass. This rubble pile is composed of layers of weak, fragmented volcanic rock, ash, and lava flows from previous eruptions. Making matters worse, the volcano has a history of being altered by hot, acidic fluids. Deep within Rainier, a hydrothermal system, sort of like the volcano's plumbing, circulates superheated water and gases. These acidic fluids have been stewing for centuries, slowly but surely eating away at the rock from the inside out, turning solid rock into weak, clay-like material. Geologists call this process hydrothermal alteration. It's like a slow-motion, internal rot. You can actually see the evidence of this in the discolored, yellowish-orange rock near the summit. The mountain is literally rotting from within. So, you have this massive, hydrothermally altered, unstable pile of rock and ice. Now, imagine new magma pushing its way up from deep within the earth. Instead of taking the path of most resistance all the way to the summit, what if it finds an easier way out? What if it pushes sideways, into one of these weakened, altered zones? That's the recipe for a flank collapse, or a lateral blast. The side of the mountain could literally fail and collapse outwards. If that sounds familiar, it should. It's exactly what happened at Mount St. Helens in 19. A bulge grew on its north flank, a sign of magma pushing sideways, until the entire side of the mountain gave way in a catastrophic landslide. This sudden depressurization of the magma system triggered a massive lateral blast that leveled everything in its path. At Rainier, the consequences could be even more devastating. Why? Because of all that ice, Rainier has over a cubic mile of glacial ice and snow. A flank collapse would be like dropping a hot rock on a giant ice cube. The heat from the collapsing rock and any erupting magma would instantly melt enormous quantities of that ice and snow. This would create something far more dangerous to the surrounding communities than lava or ash lahars. Lahars are volcanic mud. They're not like normal floods. They're thick, fast-moving slurries of water, rock, mud, and debris, with the consistency of wet concrete. They can travel at highway speeds, up to 50 or 60 miles per hour, and can be hundreds of feet deep. They don't just flow over things. They demolish and bury everything in their path. Houses, bridges, forested, all get swept away. And the river valleys radiating out from Mount Rainier, like the Puyallup and Carbon River valleys, act as perfect channels, funneling these devastating flows directly towards populated areas. Towns like Orting, Sumner, Puyallup, and even parts of Tacoma are built on top of ancient Lahar deposits from Rainier's past eruptions. The ground they're on is proof that this has happened before, and will happen again. The scary part is, a Lahar-generating collapse doesn't even require a full-blown eruption. Intense rainfall on loose material, a steam explosion, or even a large earthquake could destabilize the weakened flanks of the mountain and trigger a collapse and subsequent lahar. The mountain is so fragile in some places that it could fail without any magmatic activity at all. Scientists at the Cascades Volcano Observatory are monitoring Rainier 24/7. They use a network of seismometers to detect ground shaking, GPS stations to measure ground deformation, any swelling or bulging, and gas sensors to sniff out changes in volcanic gas emissions. This network is our first line of defense. It's designed to give us warning days, hours, maybe even just minutes before a collapse or eruption, allowing time for evacuation. In addition to monitoring, there's a huge focus on public education and preparedness. Communities in the hazard zones have designated evacuation routes and lahar warning sirens. They practice drills so people know what the sirens mean and where to go, which is always up to high ground as quickly as possible. The challenge is immense. In some of the closest towns, a lahar could arrive in less than an hour, leaving a terrifyingly short window to get tens of thousands of people to safety. So, while the image of a summit eruption is powerful, the real, insidious threat from Mount Rainier lies in its crumbling sides. The combination of its weak internal structure, The massive weight of its glaciers and the populated valleys below creates a perfect storm scenario. It's a sobering reminder that with these magnificent natural wonders comes an inherent and powerful danger. Understanding that specific danger, the flank collapse, and the lahars it would generate is the first and most critical step in coexisting with this beautiful, but potentially deadly, giant. Thank you so much for joining me to explore the hidden dangers of Mount Rainier. It's a fascinating and incredibly important topic. If you found this video interesting, please hit that like button and subscribe for more deep dives into the forces that shape our world. Stay curious and stay safe.